Well, good afternoon and welcome back. I want to thank you for joining us here. And if I hope you've had enough time to get the latest update on Simone Biles, and hopefully you're all caught up on what we won and what we lost. So I want to welcome Carol McCall here, continuing our conversation about AI in healthcare and the opportunities and hopes and dreams of automating and making the world a better, faster, cheaper place. In April 2021, CMS announced the winner of the CMS Artificial Intelligence Health Outcome Challenge. And this was the largest ever prize competition for innovators to demonstrate how AI solutions can predict patient health events. This was a 2-year competition, and it was described as an exciting example of how public-private partnerships can drive innovation. Carol McCall was the chief, or is the chief health and analytics officer, at Closedloop Ai, and she was there to oversee, watch, and support the winning submission for that prize. She's going to talk a little bit about what the prize was, how they got there, the journey she went through, and maybe perhaps as importantly, kind of the current and future state of AI applications using in healthcare. I think, there's a quote frequently attributed to Bill Gates that, what you expect, you'll underestimate what you expect to do in a year. And overestimate what you expect to do in the next 12 months and underestimate what you're going to get accomplished in the next decade. And so I think the story that Carol is about to tell has a lot to do with what we don't even understand about what will get done in the next 10 years. So Carol, without any further ado, welcome.
Well, thank you very much for the invitation to be here and spend some time with you all this afternoon. So good afternoon. As you said, my name is Carol McCall. I am the Chief Health Analytics Officer with Closedloop. And I just want to thank everybody for taking time out of their day today. So today, what I'm going to do is I'm going to share some insights into how you can go about trying to accelerate the development of AI solutions for predicting patient health outcomes. So we're going to do 3 things. I'm going to give a kind of a quick overview of Closedloop.ai. We're then going to turn and spend a lot of time on the CMS AI Outcomes Challenge and what we submitted and some of the things that we believe were different and distinct. And then kind of close it up by talking about the state of AI in healthcare, both current and potentially future. And more importantly, ways to get started and how to get rolling with a lot of this stuff if you aren't already. So setting the stage for a lot of this actually is, health IT's perfect storm. And so there's probably not a better crowd that knows all of these different details and each of you kind of what's happening here because you guys live this every day. And so there's this combination, though, it's really important, of a data tsunami and everything that's coming, the digital transformation, which does nothing more than provide more data as you go about making drastic changes to your business, and then the value-based care and the push to value-based care. And what's happened because of this special alchemy of these things as they come together, it's led to a demand for data scientists that has far outstripped the supply. And even when you could find a data scientist, they're spending the vast majority of their time on low-level tasks. And so this is from a report from McKinsey, and this was a couple of years ago now, but even then they estimated that the shortage of data scientists was 250,000, and that for what those folks were actually doing and spending their time on, about 80% of their time was on fairly low-level tasks. And so not actually being able to, not just whether or not they were being creative, but were they spending time on the things where they were practicing at the peak or the type of their license. And so that brings us to essentially to Closedloop, and so which is healthcare's data science platform. So we were founded actually about 4 years ago. Closedloop, this platform is purpose-built and dedicated to healthcare and life sciences. And the goal is to actually solve that supply and demand problem and to make it easy and affordable to use data science to improve outcomes and reduce costs in healthcare. And so when you think about the platform, there's really kind of 2 ways to think about our technology. And one of them is to think about it as kind of a workbench for data scientists. So here on the left, um, and where people that have large data science teams, they will use it almost as kind of a workbench and to build and deploy their models, to automate a lot of their clinical feature engineering, to use it for support for all of the different code sets and taxonomies and ontologies that come flying through healthcare. And really to help them as they deal with model deployment and what it means to monitor those. And so for them, it's a full end-to-end workbench for them. But there's another way that you can think about this technology, and it's as really kind of this library, this enterprise library of very rich clinical content. And so on the right, what we have is there's a template that we'll have for a lot of different models and a lot of rich clinical features. And so a company or a healthcare organization that doesn't have even a single data scientist on board can actually bring their data, and we can build them kind of custom models using their data for a lot of common use cases. And so in some ways, we're kind of like their first data scientist. And so a lot's happened in 4 years. So today we are the industry's leading healthcare AI platform. You can see a couple of demonstrations of this. On the right side, last year, KLAS launched their inaugural AI report. And what was wonderful that Closedloop was one of the top performers in the report, actually the top performer. And as you guys know that are familiar with this, this is really based on not what we think of ourselves or even what KLAS thinks of us, but what the clients of Closedloop actually think. And then, as John had said, on the left side, you can see this year we were awarded the winner of the CMS AI Health Outcomes Challenge. And this was kind of the X Prize. It was the largest ever, AI for healthcare challenge that had ever been run. And so this contest had more than 300 different entries. And these were some of the research organizations and academic medical centers from around the globe that participated and in this 2-year challenge. The key to both of those things, for us anyway, there's really 2 things. And the first is that recognizing that certainly for the AI Outcomes Challenge, it wasn't about having a model. It actually, the key was actually having a platform that could build models. And not just kind of any platform, it really needed to be something that could go from, on the left side, you see it goes from raw different data sources all the way through to deployment. And that's something that could handle whatever data we were going to get tossed during the contest or any kind of data that our clients may bring to us, and to be able to integrate those all the way through into the different data science aspects, from handling the data, building the features, training the models, and deployment, but then moving through to creating comprehensive risk profiles. We'll talk a little bit more about that. And then at the end of the day, being able to integrate this into a workflow system, because what clinicians want is not a model. What they want is something that helps them make better decisions every day for their patients. So this platforming, having this platform, was actually key, both for being awarded kind of best in class, but also to winning the challenge. Another thing that has proven key in all of this is being able to do this stuff both securely and at scale. So in terms of security, I think one of the things that is crucial, whether you are performing these kinds of building these kinds of models, or you are actually shopping for some way to get this done, is that it be secure. And so being HITRUST certified and SOC 2 certified, and being able to show that you have HIPAA compliant storage and being able to handle all this sensitive data is absolutely key. And then second is with respect to scalability, because data is really, it's only getting any bigger. I think a great example of that was the scalability required for the CMS challenge, where it wasn't really the number of tables that were involved. It was the fact that the data we got from CMS had 56,000 columns, and we ended up generating just shy of 200 billion total data points and making over 460 million different individual predictions. And so it's really the ability to do these types of predictions at scale with the data that comes through that is really kind of, it signals where a lot of organizations are going to go as they become AI enabled organizations. So that's a little bit about who we are and what we do and how we go about it. But I really wanted to spend the lion's share of the time today on the CMS challenge. So here's a little bit about it. It was launched in March of 2019, March 27th. And as I mentioned, there were more than 300 companies that submitted proposals. This was a multi-stage contest. So moving from the proposal stage into stage one, the number of companies went from 300 down to 25. Stage two took that 25 down to 7, and then on April 30th, it was finally awarded a winner. What was interesting about these is that each stage was a little bit different. And so in stage one, companies actually had to predict, quote, unplanned hospital and SNF admissions and adverse events, and in a 30-day time period. That was one goal that CMS had. The other goal was that you had to create AI that clinicians would trust. And so that was stage one. In stage two, the prediction problem was different. We had to predict 12-month mortality. It could have been from any cause, but everybody was predicting that specific thing. And then the other thing that companies had to do, entrance, was to explain how we would address algorithmic bias, which has become a bit of a hot topic as of late. So on the one hand, our CEO likes to say we were born to win, not because, out of arrogance, but the very types of things that CMS was asking us, everybody, to predict were the things that we had founded the company to do actually 4 years prior. And so in some ways, this was right up our alley. This should be something that we ought to be able to do, quite easily. And yet, on the other hand, every single stage here challenged us and pushed us so hard to do things that we actually hadn't done before. And so in the end, I think there were probably 3 things that really set us apart. The first one was how we defined each of these prediction problems. And I'm going to go through each of that in more detail in a second. The second thing that I think set us apart was how we created explainable AI. And then the third was our approach to addressing bias and fairness. So let's just kind of dig right into the first one. So this first one, if you go back, I'm actually going to back it up one slide. We were being asked to predict, again, unplanned hospital and SNF admissions and adverse events. And so if you think about that, that could be a lot of different things. So it's hospital admissions and SNF admissions are different. And then adverse events could be a lot of different things. And so the way that we approached it, some entrants tried to figure out which thing they were supposed to predict, which one was right. And we took a different approach. And what we did was we took a portfolio approach. And we actually created predictions for 13 different models. And it was a composite of 12 different specific events, and then a composite prediction reflecting your risk of having any one of those specific events in the 30 days. And we took that approach really for 3 reasons. And the first one is that it actually would help more patients. So when we added up all of the number of different Medicare beneficiaries that would be impacted by one or more of the events that we were predicting, that was 12.8 million Medicare beneficiaries. And so just having the highly explainable models and highly accurate models across that many people just meant that you could help more people. The second reason was that this type of approach was actually more useful for physicians and care managers, because when you think about what they are doing every day, a physician or a care manager, their patient population is pretty diverse. And so the things that they are being asked to address, as in their professional experience, can run the gamut. And so if we are able to present to them much more of a comprehensive risk profile for somebody, that's going to be much more useful, because someone may have their different patients have different risks. And the last thing they want to do is figure out, now, which predictive model should I pick up and try to use today? And the third reason is that these component predictions, we put 12 specific predictions, and all of those could have been modified or extended for a given population. And so what it did is it created this really interesting path for innovation and for testing new interventions and learning what works for whom. A little bit about the component predictions. These are the different specific events that we predicted. There's actually one that's not listed here. And it's we actually predicted people who would be admitted for influenza within 30 days, admitted or seen in an emergency room. And so what you see here, these are the different unplanned hospital and SNF admissions and the different adverse events. And these particular adverse events were basically based on three different things. One was, what was the data which we got capable of making a prediction about? So was that possible from the data that CMS had given us? Second was it something that could be predicted and intervened on? And does the evidence say that if you did intervene, that you could actually have an impact? And so when we kind of scoured the research, basically this was the set of things that the data could predict, actually could be predicted accurately and could be intervened on to make a difference in somebody's life. A little bit more about the data. So here are some of the data sources that we used. And so on the left, you can see that we have data from CMS, from claims. We also had data that we linked with respect to social determinants of health and environmental data. And so what we were trying to do here was to illustrate to CMS just the importance and the value of having diversity. And so you can see that even with the data from CMS, there's a tremendous number of different kinds of features that you can build, whether they are around demographics, diagnostics, procedures, or utilization. And then based on the geography where a given beneficiary was living, we were able to link a large number of sources for social determinants. One was the county health rankings. We were able to link in the USDA Food Environment Atlas data, the CDC Social Vulnerability Index, and area deprivation indices. And what was really interesting, we were able to link in environmental data on EPA air quality, CDC flu view, and some weather data. And what you can see on the right is when all was said and done, you can see what portion of the features and the models were using different types of data. So not all of the signal was necessarily coming from the same spot. You can see quite a bit, about a little bit more than 20% from diagnoses, but you can see that close to 7% was coming from social determinants of health data and another 2.5% from environmental data, which is really interesting. In terms of performance, I realize this is a bit of an eye chart, but what this is a table of the different accuracy statistics. And so you can see that for each of those models there, that the AUCs, the area under the curve for the receiver operator characteristics, they range from a low of 0.76 to a high of 0.93. But overall, for that composite event, they were really strong. So they were 0.81. And so they were all very well, very accurate and very well calibrated that you can see here. And they were, 3 to 5% higher in terms of AUCs than what we were seeing in some of the published literature. And some of that actually had to do with both the diversity of the data, but also some of the features that we were able to create from the data. The second thing that was a key, as I mentioned earlier, was explainability. And so what you're looking at here is something that we created for the challenge. And this is one of our patient health forecasts. And what you're seeing is kind of that front page. This is actually a 10 to 15 page full risk report. And what it does is it allows a clinician to view the full detail of a person's risk over time. And so you can see there that in this particular case, you're looking at a patient whose risk is rising over time. And you can see there's a kind of in the middle of the screen, a panel with factors there. And what those are telling you are, for any point in time, what's contributing to somebody's risk to make it higher. And those factors are shown in red. And what is actually serving to make their risk lower. And those factors are shown in green. And this actually exists as a dynamic interface. And what you would see if you move the cursor over time is you would see those risk factors begin to change. And what they're doing is showing how, as a person's health changes over time, how their risk is changing in association with that. And what they do is they actually tell a story. of the factors and how they are increasing risk, but also how they are serving to make the risk for a specific event either higher or lower. And so for us, this was key, because what it did was it completely reimagined the concept of a risk profile. What this does is it kind of shifts away from actually having a score to giving somebody this really comprehensive forecast for each patient. It gives you this longitudinal view to kind of harness all of the different data that you may have for your patients or your organization, and it surfaces these variables, that explain each risk. So if we want AI to be trustworthy and give physicians something that they'll trust, what they need is something that they understand, something that explains why a prediction is what it is, and that you can actually drill down into the very specific, even down to the data element, what claim on what day or what test with what result actually lend itself to that. And then these things, they can also integrate specific interventions based on this, that if an organization or a physician says, when I have a patient that looks like this, if they want to have a specific intervention, then it can link so they can reduce that risk or improve the outcome. The third thing that we did, I want to turn and talk a little bit about our approach to addressing bias and fairness. So the third thing that we did was apply a framework. And so this is a fairly busy slide, but what it is, it illustrates a comprehensive framework that had been published a couple of years ago by Paulus and Kent out of Tufts University. And what they're doing here is something that's really important, is that they're laying out kind of a step-by-step framework for identifying how algorithmic bias can creep in and what you need to do to examine whether or not it's present. They also do something else that's important, is that they distinguish between what is algorithmic bias and what is algorithm, when is an algorithm fair or unfair. And those are two distinct concepts that they go through. They also go through what, back on the left side in terms of bias, where it can creep in. And one of the important things for healthcare is looking, not only is my data representative of the people that I'm trying to make predictions for, and how to identify what's called subgroup validity, which is making sure that if you're trying to, in this case, we were looking at model performance by race and ethnicity, is every subgroup valid with respect to its performance? You also have to consider something called label choice bias. And a label choice is actually the decision that a modeling team makes about what it is that they're going to set out to predict. And there have been some articles recently published that have established that using cost as a proxy for someone's health risk carries a lot of implicit bias, because costs go up and down for reasons that have nothing to do with a person's health risk. And some of those reasons capture and reflect kind of systemic differences. In the end, what it means is that if you use a label or a prediction that is biased, you can end up enrolling people in programs in a rate that is different based to their actual healthcare need. And so we were able to go through and use the CMS challenge really as a giant demonstration of applying this framework. And so we went through every single one of these steps, looking for representativeness, subgroup validity, looking for label choice bias, feature bias, and sampling bias. And then we also looked at algorithmic fairness. And to do that, we actually did one other thing that was really important. We actually developed and applied a new metric for fairness. And this becomes very important because when you look at measuring fairness, there are different families of fairness metrics. And the right family depends on the context that you're using and that you're measuring. And as it turns out, some of them, they're actually inappropriate for healthcare. So some of the most commonly applied measures outside of healthcare actually don't work well in healthcare. And they lead to these kind of nonsensical results. For example, that men and women must have equal risks of breast cancer. That, of course, that's just not true. But the way that the measures are built, they cannot adjust for observed differences, in event rates that you would expect. Other families weren't appropriate for the challenge because they require, kind of causal modeling, which is generally can't be assessed using observational data. And then another family of measures, it closed some of those issues, but at the end of the day, it wasn't able to account for differences in observed rates in ways that are important. So we created and have published on a new fairness measure, and it's called Group Benefit Equality. And at the end of the day, without going into technical details, it basically says, are groups being allocated resources in proportion to their observed need? Specifically, it identifies a criteria that a model has to meet if it's going to be fair. It also helps you know the degree to which it is unfair, if that hasn't happened, and gives you an actual quantified threshold adjustment that you can use. If you have unfairness, you can actually make an adjustment to your program that'll bring it back into balance. And so that's the last thing that we did with CMS was we actually illustrated this within the context of the challenge. We found a couple of places where the models needed adjustment. And you can see that on the left of these graphs, you can see that there are 2 bars that are below 1. It was for Asians and another group that was just kind of other and unknown. And if you, with the threshold adjustment that was created and calculated by this, we lowered the threshold adjustment from allowing, say, the top 5% of people to be targeted for a program to saying, let's actually target, 7.7% instead of 5%. So let's target a few more. And when you do that, it brings the group benefit equality threshold back to 1. You would enroll, in this particular case, about 6,600 more Asians would be selected for care management. And so then you would have a program that was not only unbiased, but fair. And so I think those 3 things, the approach to bias and fairness, a high degree of explainability, and these comprehensive portfolios of accurate models are really what set us apart from our competition in the challenge. So if we turn away from the contest now and just say, clearly, AI for healthcare, it's starting to come of age. And so the last thing I wanted to do today was really talk about the state of AI-enabled healthcare. Because I think if there were ever an industry that needs AI's capacity to create deep transformation, it's this one. So I think as we all work in the industry, we know that their healthcare organizations are facing severe challenges, some that are severe enough that they may only yield once you're able to bring AI to bear. It's kind of this irresistible force meets the immovable object. You guys every day face these forces of whether it's eroding margins in terms of fee-for-service revenue, consumerization of healthcare. Here come the platforms. There's new competitors every day, and all of the accelerating value-based contracts. But on the immovable object, that's really cost. It's interesting. I had been reading that the Medicare Trust Fund is projected to be exhausted in 2024. It's the closest we've ever been to that point in the 55-year history of Medicare. The number of uninsured Americans is rising again, and affordability is eroding. And I think the already unacceptable, disparities, they're already high, and just what we've seen just from the revelations from COVID. Now, the good news is that there's no shortage of opportunities. And so every single one of these use cases is possible today with data that's readily available. And so whether you're talking about adverse events, clinical conditions, quality and safety, patient vulnerability, medications, revenue and operations, or healthcare costs, every single one of these use cases is something that I've had an opportunity to work with somebody on, and they've been able to put either interventions or operations around to make a serious impact on their business. And so for a lot of them, though, the question has really been how to get started. And so what I've had a chance to see successful companies do is that they actually set out to do 3 things. They tend to start small, move fast, and try to expand over time. But they begin by trying to identify candidates. Then they refine those and then try to align them. In terms of identifying candidates, they really focus on where is there some sort of unmet need, where is the data available, the circumstances predictable, and the desired outcome. Let's say I'm trying to prevent, an unplanned hospital admission. I can actually do that. Evidence suggests that I should be able to do that. But then it's once you get those candidates, it's refining the selection. So do you have an intervention that exists today, or one that your company is prepared, to invest in? Sometimes if you have an already existing intervention, the fastest way to an ROI is just kind of refining the accuracy of the people that you're already intervening on. Also find something with a short time to impact. If this is going to be a big, initiative for your organization, the faster you're able to show, an impact, the more likely it is that you'll be able to gain momentum and make further investments. And also pick something that can be readily evaluated, so that the boss is going to come down the hall and kind of say, is this thing working? And so having that idea and that question in mind and using that data to learn what works for whom, the better off you're going to be. And then last but not least, I've seen organizations do really well when they pick their strategic initiatives so that they're aligned with another one. So maybe they're leveraging new data, or they're creating new data. Maybe they're doing it to enable a new contract or a partnership, or in some way that it's creating a competitive advantage. But those are the types of things that I've seen, be the most successful. But in the end, I will say, organizations, they're going to be managing entire portfolios of models as they become AI-enabled organizations. So, and I enjoy working with everybody, and just really excited to see some of the things that people are able to do with them. So thank you.
Well, thank you, Carol. Wow. We know every payer in the country, or most payers in the country, their most aggressive line of business expansion has been in the public sector business, precisely because they believe they can create margin by building programs and using targeted knowledge. And I think you've clearly shown how far the boundaries of what can and should be done and where it should be done are growing rapidly, and you're showing how that really works for you. I think if payers aren't thinking about what you're doing right now, and they're in the Medicare, Medicaid business, then I suspect they won't be next year.
Right.
So we did get a couple of questions. First of all, a plea not to say anything more about anything that's happening in Olympics, because some people are going to be watching later, so I'll stay away from that. But let's see, my message Q&A disappeared. Michael, my comments window has left me. Can you jump in here? There were 2 or 3 I think from a couple of people who asked.
Sure thing. Janice Karen asks, if you were using manual examination via these steps to reduce bias, did you do pairing or multiple passes to try to avoid the implicit biases of the people doing the evaluation, or were there other steps you took?
I'm not sure. I'll do the best I can on this. So I see it written here, Janice. The people doing the evaluation work. I guess if you're talking about the evaluation work, are you talking about the people that, I assume you're talking about the people that were judging the challenge.
Actually, Carol, I've asked Janice to unmute so she can clarify.
Oh, great. Perfect.
Hi, yes, this is Janice Karen from the Massachusetts Health Data Consortium.
Yeah.
That question, actually, I put it in when you were talking about judging the biases in the data and going through that multi-step process of sort of unbiasing the data, although that's, or whatever you want to call that.
Right.
Yeah. So it was more of if you're doing that as a manual process for people looking at each of those steps, how do you keep the biases of the person who's doing that from sort of infecting the data?
Oh, right. There's several steps in there. So the first of all, it was a lot of these things they're calculations that you can perform, right? So I understand what you're talking about, that we all bring certain biases to a particular situation. And I think maybe what you're talking about is when you make those final, adjustments, it has to be a multi-stakeholder, process. At the end of the day, making an adjustment for a program that is to make it more fair, you can't do that necessarily with an algorithm. It has to be a conversation and a decision that's made by people, right? We've created some calculations that we think can aid that conversation, but they don't replace that conversation, if that's what you're talking about. Did that answer your question, Janice?
Janice, did we lose you?
Sorry, I muted again and I couldn't unmute.
Okay.
Yeah, no, I mean, I guess that's a fair start. Maybe I'll ping you offline and continue the conversation. I don't want to derail everything.
Okay, very good.
And Janice, you had another question. Explain.
Yeah, sure.
What the
Should I just
GVE
ask
metric?
it? Yeah, could you just, maybe I missed it, but what is the GBA metric and how does it work? It's not something I've heard of before.
Right. Yes, it's a fairly straightforward measure, and it is a ratio of the predicted risk for a group divided by the actual risk for a group. All right, and the predicted risk is, for those of you that can withstand a little bit of jargon, it's the true positive plus the false positives. So it's everybody you said was going to be positive, whether you were right or wrong, right? Divided by the actual risk for a group, which would be the true positives and the false negatives, right? So those are people that really had something bad happen to them in the denominator. And what you want is you want that ratio to be 1, okay? And to the extent that you are under predicting somebody's risk, right? Let's say that you have a bad thing happen 10 times, Janice, and I only predict 8 of them. And that means that, let's say, if every time I predict something, I offer to help you out, it means that I'm not going to be helping you out as often as you might need, right? And so when you systemically underpredict somebody's risk, then, and when those predictions are used to make what these researchers call a polar decision, which is when I have only a scarce amount of resource and I'm using risk, my predictions to allocate those scarce resources, when I underpredict systemically certain groups of people, then I am systemically excluding them from those resources. And this measure of predicted to actual risk helps know the extent to which that might be happening. And also it solves problems that other measures of fairness don't solve but need to be solved in a healthcare situation. So we actually have a blog on the topic over at our website. So if people really love to kind of get nerdy with stuff, head on over and give it a read.
Carol, I think that answer highlights another question that kind of came to mind for me. A lot of the competition in the marketplace, especially when you're talking about measurement, quality measurement, measuring value versus, either quality or cost. A lot of this they're very specific measures. So payers who are in this work and these lines of business with Medicare, to a large degree, they're managing to the measures, right? So CMS says this is how we're measuring. And when you explain some of the things you did there about how you have very sophisticated, very granular approaches to understanding a measure and then winning under the measure, as we get into commercial populations, as CMS starts to fine tune and decide that payers are making too much money, and these measures change and the models change, how flexible are these AI tools today to be able to adapt to that? Or is there a lot of development that has to happen within the technology itself to be able to be more fluid and agile?
Yeah, no, I think that's a great question. And I love your use of the word agile. And what I would suggest to everybody is that, because all these measures are going to change. And so what you don't want is, you don't want to build your models using a technology that's really brittle, that requires you to, every time something changes, you have to boil the oceans with all of this. And so what I would say is that the platform that we've got has that kind of agility to it. And so I know that I was kind of spouting off some measures about how many predictions we've made and all that. We made 460 million different predictions. And it wasn't because there were 460 million different people, but it was because we were testing all these different combinations of variables where we'd calculated them in, you know, some different ways, or we had different combinations of them, so that we could see which ones actually were the most accurate. And so the technologies have gotten to the point where it is possible to make to calculate all of those different measures and those features, and to make adjustments on the fly, you know, and create a new set of models very, very quickly. And my recommendation for anybody that's out there purchasing something is that to ask questions just like that of somebody that you're going to buy from, or maybe if you're getting ready to build something, and make sure that you don't create something that's super brittle. Because if there's one thing that we know that we can expect, is that there's going to be a lot of change in our future with respect to value-based payment contracts, new measures around quality, and things like that. And as those change, you're going to want to incorporate them into your AI.
Carol, thank you so much. Fantastic presentation. And once again, congratulations for winning the CMS AI Challenge Award.
All right. Thank you, everybody. Have a wonderful day.
You too.
Thank you, Carol.
Bye-bye.
As we're wrapping up this session, inviting you to our final educational session, looking at the AATG, WEDI's Administrative Automation Task Group, will be meeting to kind of bring everything that we've learned together. Feel free to offer questions that you've had throughout the day. John Zimmerman, Dave Haugen, and Rob Tennant will be there shortly, in the next couple of seconds. We'll see you there.